So this problem is actually very, very tricky. We have 3 slots here. And, well, obviously the first letter can have 5 possibility and second letter can have 5 possibility. The restriction is that each letter can be used at most twice. So, well, the third slot is very problematic because this is 4 if these 2 letters were the same. But because we put 5 and 5 here, we're letting any letters to be the first 2. So they don't have to be the same, but they can be the same. So the third slot can be 4 or it can be 5. So we can't really go about it this way, doing it one fell swoop. So this is when you know that you need to split them up into different scenarios in order to account for everything. So here I'm going to split it up into the scenario where there are 2 of the same letter, and then also another one where they are all different letters. To have the same 2 letter, let's say that the first letter can be any of the 5, so we have 5. And then the second letter have to follow the first letter. So there's only one way for that to happen. So these 2 are the same letters here. The first letter is any letter, then second letter follow the first letter. And then that leaves the last slot to have 4 letters because this letter have to be whatever these two aren't. And now we have to take that times 3 because the same 2 letter can be the first and the second, first and the third, or second or the third. So it can be first 2, the last 2, or 1 and 3. So that's why we take it times 3. So here we have basically 60. To have all different letters, oh, that's easy. So that's going to be 5, 4, and 3, because whatever you use here can use here, and whatever you can't use for these 2 can use here. So that's also 60. And these 2 scenario is either or, so we're going to add them for a total of 120. That's your answer. Now, there's a much easier way to think about it if you somehow notice. When I first did this problem, I didn't notice myself until I saw the answer. But another way to think about this is, so let's assume that there is no restriction on each letter used at most twice. So let's say each letter can be used 3 times. So each letter used any number of times. When that's the case, so we're going to have 5, 5, and 5, because there is no restriction. Each of the 5 letters can be in each of the 3 slots. But when each letter can be used any number of times, it violates part of what the question is asking for, which is each letter used at most twice. So we're going to subtract out all the one that broke the rule. And the one that break the rule is when they are all the same letter. 3 times. Which, the number of ways to do that is, well, the first letter can be anything, and the next 2 letters have to follow. So it's 1 and 1. So doing it this way, we have 125 minus here 5, which comes out to also 120. So here's interesting, you can see that it's a very different logic going through these 2, but it gives the same answer because the logic is correct.